WarsawJS.
Hello everyone and good evening. Let me first quickly introduce myself. My name is Piotr. I've been a software developer for many years. Currently I'm working here in Paramount. For now I'm involved in developing streaming application in React Native. Previously my main focus was mobile app development, mostly Android, Kotlin. In past, I was also developing software in JavaScript and C++. Today, I'm going to talk about possibilities of rendering graphics in a web browser using WebAssembly technology. This is basically my first speech during WarsawJS. I'm glad I'm hearing such a big audience today, and I am a little bit excited. Okay, first I will briefly discuss about what the WebAssembly is. Later I will give an overview of the project, what I am doing, and describing its technology stack and architecture. Based on my project, I will discuss some WebAssembly related aspects like building application process, setting up rendering window, and how to create a communication bridge between JS and native code, and how can we use a virtual file system on web in native code. What is WebAssembly? This is basically a binary instruction format, and thanks to that we can compile native code, in example C, C++, Go, Rust, and run it in a web environment. Since 2019, WebAssembly is a standard announced by W3C. Since we have this, it opens a lot of new possibilities for developers. Okay, so what capabilities does it offer? Most important thing, of course, we can, when having a native application, we can possibly compile this using WebAssembly and run on web. We can render 3D graphics. This is what I will be talking mostly today. We can have multi-threading. We can access file system. We can leverage this for doing some high-intensive computation. And there's like easy way to create a communication interface to JavaScript. Who uses WebAssembly? So first, when I start learning about WebAssembly, I was really surprised in how many web applications currently utilize this. So like among of them, there was some application that I was using so far in personal life and at work. In example, Figma, Lichess, yeah. So like if you go to the website, so there's more than 100 websites mentioned that utilize it. Okay, so what is my project about? So first, let me bring up a little bit history, and I will tell how I learned about WebAssembly. So in past, I was a little bit interested in rendering real-time graphics. I was also working in a company that was involved in mobile game development. So one day I thought it would be nice to leverage this interest and develop something useful and have it as a side project. So my idea was to create a lightweight 3D engine for rendering interior spaces in the buildings. it could be useful for things like space reservation, booking rooms, and also for navigation in a bigger area like airports or shopping centers. Okay, I will tell how I start this project. So I start with desktop application for a prototype. So like I did some simple library first on Linux and Mac OS. When I had something that was working visually, I poured this to Android. But of course, like the majority of the users are using a web browser. So like the next natural step for me was to find a way how can I run it in the web environment. Since I am not doing web development on daily basis, I was not sure how can I approach this problem. And one day at work, when we had a coffee break, I was talking with my colleague, Rafał. Rafał is here. Hi, Rafał. And I showed to him my prototype working on Android. And we were discussing how can we move this to the web. Because like I was initially thinking that I could use WebGL and like rewrite this in JavaScript. But Rafał told me, let's take a look into WebAssembly. And basically, that's how it all began. Before I will show the prototype, there's one important thing to be mentioned. I'm going to render 3D building indoor. So like I need input data in vector format. First, IMDF format. It's designed by Apple. And it is compatible with RFC, with GeoJSON, described in RFC. It provides some basic shapes like polygons, polylines, and based on that we can have a lot of objects like furniture, walls, chairs, and so on. Okay, let me show my prototype. Okay, so here's my application working on web browser. What you see is like 3D building model. This is Paramount building. It's where we are right now. So there is, you see all the floors. Let me select floor number 1. Yeah, so here is our room. I'm sitting here. You are here guys. And here is, I think here is pizza, or not. Or not yet, okay. Yeah, I can go back to the whole building view and let me maybe select any other floor. Let's say -2. It's like parking area. There's also possible to like in my prototype to display separately all the types. So I render walls, furnitures, rooms, and, floors. Yeah, so enable this again, and I can use some free browsing mode. So it's like this mode is like in 3D game. So I can rotate camera like in FPP game, and like move around buildings. So my camera model has 6 degrees of freedom. I can move in any direction and rotate through any axis. Yeah, so like we can see this closer. Okay, so like that's about the prototype. As you see, I do not support so many objects yet. So like you see, like seats and tables and room and walls. That's it. IMDF offers much more extensive, list of models. So like I will be supporting this in nearest future, I hope. Let's back to presentation. I will discuss technology stack and architecture. So this is our stack of pure engine. I'm using C++, standard 11. For graphic pipeline, I have OpenGL and OpenGL ES 3.0. Very important thing to be mentioned here, because OpenGL ES 3.0 is the same what I use for embedded for mobile devices on Android. So like by default, it's initially I had implementation for Android. So having working model in OpenGL 3.0, I almost get this working on the web version for free because it's WebGL is compatible with this. What else? GLM is graphic mathematical library. There is GL framework and GL extension Wrangler. There are some additional libraries that helps to set up OpenGL and set up window for rendering. For building, I use CMake. There is also EarCut library for polygon tessellation and library for parsing JSON in C++. And here is an overview of architecture. So like, let's start here. So there is IMDF vector data. It go to the parser. Parser builds a data model from it. They go to renderer, and on top of this, there is Scene API. So this is like interface for user of the library. So by Scene API, developer can define everything what is related to the scene, like position of the camera, set of the lighting setup, and load data model. On the right side, there are libraries loaded that I just described, and on top of this, there is WebAssembly. To glue and build everything, and on top there's Java script code when everything is like executed. Let's see how the building process worked. Important thing to compile WebAssembly, I need a special toolchain. There's CMake and mscripten. Mscripten is dedicated toolchain for WebAssembly. There's a simple command I call emcmake space make. It builds the template, and I call make, so it compiles engine code and web native code all together. On the right side, there is CMake. It's build configuration. For web app, so like, let me give quick overview. I define C++ standard, and here I include headers and sources. So I mentioned I compile everything all together. So here I include headers for web project, and below there is I include engine headers and library headers. Also. Here I include sources, the same for web project, and separately for engine. Below I define output file, and what is the output of the build process. So it generates some binary file plus .wasm.js file, which is some kind of glue code that for JavaScript. And below I attach some settings. So like I enable in the setting list, I enable WebAssembly, enable GL framework, enable OpenGL ES 3.0 and WebGL 2. Yeah, and that's it about building process for now. Rendering window setup. I think this is the most crucial part from our presentation to date. So this is how we create a rendering surface and make OpenGL access to it. So there are three snippets. One is HTML So I create basically a canvas. Here is a JavaScript glue code. So I find this canvas in the DOM tree and assign this to the module.canvas. What is module? This comes from this generated code during build process that I talked before. So when I assign this here, the canvas became a default drawing surface for OpenGL. Below I am some resize when native code is initialized. So there's on line 10 there's callback module.on runtime initialize. I set some small timeout, and like it gives me an event when native code is initialized. On the right side there's C++ code to create a window. There's one thing important to be mentioned. If you would, in example, download some GL framework template, you would see exactly the same code, a part of this mscript and .force, because it's WebAssembly dedicated. So like, but the setup of GL framework is exactly the same. So like in line 12, I'm creating window. Above, I'm setting the version of OpenGL and set the sampling, and like below, I resize this. Yeah, and that's it. It's very, very simple for initial setup. How does JavaScript talk to C++? So as you saw on my prototype, when I change a floor or interact with the map, so it's reflect in the building scene. This means that JavaScript event must go to the native code. And how does this happen? So also there is inline first, starting from JavaScript snippet, there is module.cwrap. So this method creates a handle to native method. So as a first parameter, focus floor, this is name of the method in native code. Null means I return void. In array, there is list of parameters. So focus floor takes one parameter, it's a number of the floor, and resize take width and height. Here's important line to be added in CMake. So I have to, in CMake, I have to add flag exported function and say about, and mention all the functions with underscore prefix. So I have more method that they show, but you see focus floor and resize is also there. So like WebAssembly will generate those methods under the hood. And in the C++ snippet, there are equivalent methods, focus floor and resize. So like if we call focus floor or resize in JS code, it will call directly function in C++. How can we access a virtual file system from native code? So in case of my project, I utilize this virtual file system. It's I use it for loading IMDF data and also loading shaders. In case of rendering graphics, shaders are very important, because without shaders I cannot set up properly rendering pipeline. So like in modern graphics library, OpenGL, Vulkan, DirectX, like shaders are important part. And thing is, they cannot be compiled during a building process, because they have to be compiled in the runtime on the graphic card. So the flow is like application starts, it initialize, and shaders are loaded from external files, and OpenGL compile them during runtime, and then initialization is complete. Let's see on the CMake first line. So I use like a preload file on the left side, there's public asset. This is reference, this is path to the assets on the web project. Under we have like web public, and there are my assets. On the right side, there's reference to the root, how they will be accessible for the native code. In the next snippet, you see I load assets /imdf, and I load shader, vertex shader and fragment shader. And there is in C++ snippet there's read file function. So I pass the file name, and there's like simple file input stream to load this. Okay, this is I think last slide. Yeah, so thank you all for your attention, and I'm sorry for one thing, because this is JavaScript conference and I did not show a lot of JavaScript code. You saw mostly C++, but let's also let me give a quick summary. I think WebAssembly technology is something very interesting. For sure, technology itself deserves for much more extensive presentation. Today, I just highlight some of the aspects of it. Okay, so again, that's it for my side, and thank you very much.
First, let's give another hand to our host today, Paramount. Thank you so much, sir. We have questions? Mehdi will come to you.
Hi, I'm interested in your development experience in this project. I know C++ on its own can be, challenging in its experience, and with the additional binding layer to JavaScript, how was debugging, any surprising bugs that you've had because you needed to connect that and cross this bridge?
Great. So like as I mentioned, I start with desktop application. So like the 90% or 100% of engine code I wrote in desktop application, because I can use Visual Studio, C Lion, and so I can easily debug pure engine code there. So if there's a problem to be debugged, I run this on the desktop because it's easier for debugging. I honestly haven't tried debugging on the web. You can use Chrome web tools. That's working for sure. But I haven't tried this personally. But having this on the working on the desktop save a lot of time with debugging. Are there any more questions?
Another one question. If you're talking about C++, it has access to a lot of low-level stuff. And if you're talking about WebAssembly and browsers, is it running in some virtual machine, or is it have some other limitations related to low-level stuff?
Not sure about this. So my project is not very tough. So I haven't pushed much load there. I don't use much multi-threading, and I mentioned about virtual system, so I don't load a big amount of data. So I think it's so this binary format use basically the hardware what you have run this on the hardware what you have on your machine. So but I'm not able to give very specific detail about this. Hope this answers your question somehow.
Not actually not what I was asked about. First of all, it's related to security stuff, accessing low-level memory or some other stuff. And another thing, it's accessing events in browser and so on, as JavaScript works with event loop and so on. And if something makes this event loop busy, it makes all in my project, I also had something like this, and we had an issue when it was embedded in a page, and with some other rendering and with some other stuff, event loop was busy, and the 3D stuff start lagging and so on because of this. So if you're talking about WebAssembly,
What is the question?
is it the same issue? So does it has access to some browser events, like to the user input and so on?
Haven't checked this, so but I think you can utilize JavaScript for this. So like if you mean about like some DOM3 events, so you can catch this in JavaScript and propagate to native code. Regarding rendering loop, I did not have the problem that it was busy. Because like I render on only graphics, and the events are not giving so much load to make this busy.
We have time for one more.
Hey, you know the library you mentioned, is that open source?
What I showed?
Yeah.
No, it's developed internally in our company, so it's my side project. So like I do
You
this.
can't show things that I'm
sorry?
That's okay.
It's it's not for now in public, but like my goal is like to publish this later as an open source.
Great answer. We love open source. Yes, everybody? Okay, that was great news. And once again, please thank our speaker for a wonderful talk, and it was very informative.